everyone. I'm so excited to be here today. And today we're going to talk about enterprise GraphQL and how you can use it to leverage and upgrade your tech stack. So really excited to be here. My name is Tracy. I am the CEO of a company called This.Labs. We are hiring, so definitely hit me up on Twitter at LadyLeet or email me, tracy@this.co. I'd love to chat with you. We do all things JavaScript and we work with really cool people like Google, Twilio, Cloudinary, Wikimedia. It's a fun time here. I'm also a Google developer expert for Angular in the web. I'm on the RxJS core team, a Microsoft MVP, and I just love everything community. So again, hit me up on Twitter and I'm always happy to chat.
And hi, I'm Dustin. I'm an engineering manager here at This.Labs, and I am a JavaScript and anything web-related consultant. I love giving talks on things like GraphQL and Angular. I used to run the Atlanta Angular meetup and just love community-based organization around technology. So I'd love to work with you.
Yeah, Dustin's fun to work with, so highly recommend. So today we're going to talk about quite a few things. So first of all, we're just going to cover what is GraphQL. Some of you may have heard of it, have been excited about it, but we'll go through some basics. Then we'll go over the differences and advantages of GraphQL over REST. We'll also talk about enterprise adoption and kind of the biggest determining factors around that. We'll talk about migration strategies and what we recommend. And then we'll look a little bit with GraphQL in action and talk about the GraphQL ecosystem and hopefully show you a little bit of tooling that you can use to debug and test your API. So first to start, what is GraphQL?
So GraphQL is going to be a query language that defines your API. It's really great because what it's going to do is it's going to define all of your data through types that are statically typed, and you can access through any data method that GraphQL provides. So they have ways for you to retrieve data, manipulate data, and listen to changes on that data in specific ways. And what's great is it doesn't force you into the old REST paradigm where you have to listen on all the data. You can tell it exactly what data you want and also what type of data it is that you're listening to. And this is going to give us several advantages over REST, which is why we're seeing such a strong adoption across enterprise organizations. One of the things we see the most is how the adoption of GraphQL is actually helping to lower communication barriers between front-end and back-end development teams and creating this common schema to allow for accelerated development, which leads to higher product resiliency and a decreased time to delivering products to market, which is really awesome for your teams. So first off, it's important to acknowledge that the most expensive, resource-intensive, and time-consuming part of any client to API communication comes from the HTTP request process. And with that, we're going to look at some of the limitations of traditional REST and talk about how GraphQL is actually seeking to solve some of these problems. So for starters, let's talk about the query language. So GraphQL ships with this SDL out of the box that declares how queries are going to be fetched. So on the left here, what you're going to see is we have a query that is trying to fetch a single user and a few specific fields on that user. So ID, name, email, and role. And on the right, we can see an output from one of these GraphQL queries where we get exactly the same shape that we put into our operation. This is really nice because as I'm a front-end developer trying to integrate with a back-end service, I now know the exact shape and form of the data that I'm going to be getting while I'm writing my query to it.
So one of the first problems we're going to talk about, and one of the major problems that GraphQL solves, is just improving performance by optimizing the data retrieval process. So not going to say that, GraphQL solves all your performance issues, but this is a pretty cool example. So with REST, one of the key problems is going to be underfetching or not getting enough data back from your request, right? So this is going to require you to do one of two things. Either the client is going to have to make multiple calls to fetch all the required data, or the client is going to have to provide additional query parameters that are poorly documented or hard to understand. With GraphQL, though, you're able to request the exact data you need in full with a single request, and it eliminates these multi-requests and allows you to specify the additional data in a really clear manner. So in order to demonstrate underfetching, let me go ahead and show you this example right here. So here's an example where we need to display a user's profile with all the comments they've made on the system, right? So on the left, you see that we're fetching, making a traditional call to an endpoint that requires the user's details. Then on the right, we additionally fetch the user's comments. So here, we've had to make 2 round trips to the server to return the data we need to fulfill our requirement, and that's kind of annoying. However, magical GraphQL comes in, and this is the GraphQL query solution. So on the left here, we have our query defined where we fetch our user's data along with its comments. And then on the right, you can see the response where we get all the requested data in a single round trip to the server. So in the case of this single operation, we've actually increased our client-side performance by at least 2-fold. How amazing is that? Now, the other problem, of course, on the other side of underfetching is going to be overfetching or getting too much data from the server. So because REST doesn't provide any out-of-the-box mechanism for us to retrieve only the data we need from a request, this can lead to our clients having to consume or parse or handle too much data, or maybe our server responses take too long because, you know, the requests are just too large, right? So I've seen projects where, you know, a request for a page had to fetch over like multiple megabytes of data to render correctly, which was not fun. But the amazing thing is that we can remove the superfluous data from our request and reduce the payload size and data required to parse. So if you look at REST, right, so suppose there's a requirement to display a list of users to view in a table with their last comment and post, right? Our user object can be super large and it can contain tons of different fields and properties. We know about the user, maybe it's like comments, posts, when they were created, last updated, but we don't need all that extraneous data, right? Like we just want the basic details. So here you can see how we could have requested this data in a REST API, and it gives all the user fields and a list of all the comments and posts, right? But the request is going to take longer to return and has so much more data for the client to parse because we don't know the exact shape of the data. And the user, unfortunately, is the person who pays the price for this with the slow response and render time. Now, with GraphQL, though, we can select the exact data we need to display, not display. And now we only have the lightweight response data to display. And this really helps reduce, right, in contrast to the REST solution, both the server response and the client render.
Another issue that we're going to face in a traditional REST system is going to be the all or nothing solution in responses. So in traditional REST, you're going to make a request and something funky happens on the server. Either you're unauthenticated, you couldn't find a resource, an error occurred. You're going to get a 400 or a 500 response, and you're not going to get any of your desired data. Like it's going to die on you. And we don't want that. We really would like to be able to show at least the minimum amount of data that we could have retrieved given a partially successful request. And that's what GraphQL is going to allow us to do. Instead of saying, hey, I couldn't process any part of your request, so I'm not giving you any of it, GraphQL says, hey, I wasn't able to process this part of the request, but here's the rest of the data you asked for. So now instead of blank error pages or gross client error handling, we can just show these partial responses and inform the users of any errors that occurred in their specific containers, which allows us to give a user a much better experience because they're never going to see no data. They'll see something at all times. So looking at REST, this is kind of what a traditional call would have looked like. We would have requested our users and our comments. And let's say in this example, we were able to get the users successfully. But then when we went to go fetch the comments, there was a hiccup. We forgot a comma somewhere. Something was bugged and it made it to production. We never caught it. Well, what's great here is or what's not great here, apologies, it'll be great in GraphQL, but what's not great here is because of that failure, now we get a 500 response. It's an internal server error. We don't get our data. And now we just have kind of a failure. We have to be like, hey, we aren't able to solve your problem. Here's a gross 500 page. But with GraphQL, what's really awesome is, as you can see in my response object here, I'm getting all of the user data. So I could still show the user, but I'm not going to be able to show their comments. And that comes back as null. But in the errors, it says, hey, here's an internal server error. We could pretty this error up as we kind of identify what the core problem was and make it a little more obvious to the user what had happened. But this gives us the ability to inform users of what happened. Why are they not seeing some of their data? Additionally, what's really helpful is in development mode, we can actually expand upon this debugging information. So this errors key in the response actually allows us to inject more information, such as a full stack trace. However, this is a production response. So we don't really want to show that in a production environment, which is why it's omitted here. Another great thing that GraphQL kind of solves out of the box is batch requests. In REST, out of the box, you can only hit a single endpoint and retrieve data for that single data set at a time. So I can get a list of comments. I can get a single comment, list of users, single user. I can't get both a user and all of its comments without some crazy data manipulation in a way. And what's really great with GraphQL is it comes out of the box with this ability to formulate queries and send them in a single request and get all of that data back. This makes it so super data intensive pages such as dashboards, where you're collecting a lot of data from many data resources and having to display them in unique ways, becomes more streamlined. There's a caveat, of course, which is batching by definition will cause a slowdown. And that's because you're going to be fetching more and more and more data. So be careful how you're leveraging batching. We definitely recommend only using it on the server side. But there are ways that you can use it on the client, and we'll talk more about that when we talk about Apollo Client. But looking at an example, on a traditional REST dashboard, we might have to request a user, some information about sales, some information about marketing, and we want to collect all this data and display it across this dashboard. In this instance, we would have had, from our client perspective, make 3 unique requests. So that's 3 back and forth requests to the server. They could happen in parallel, but that's a lot of time that we're losing to these single requests. Now, we could create our own custom batching operation, which also handles this, but that's a lot of boilerplate and overhead for something that's pretty straightforward given the promise library in JavaScript these days. Now, with GraphQL, what's really awesome is we're creating a single query operation. So in this case, we're creating a query called dashboard, and dashboard can actually operate on a bunch of different query operations. So user, the sales dashboard, the marketing dashboard, takes in all the parameterized options and spits back the exact data we wanted in the exact format we wanted, all in a single request. So this makes generating those dashboard pages super streamlined and easy to do.
So I think that by now you guys have been fully convinced that GraphQL needs to happen, but we definitely want to sit and talk about why enterprises are adopting GraphQL and kind of the reasons that you can sell to your manager, or if you are a manager, maybe these reasons will help you adopt GraphQL.
Yeah, convince people like me.
So the first reason, and one of our favorite reasons, is being able to create a separation of concerns. So you can do this by adopting a GraphQL middleware layer. So this isn't the path that everybody chooses to adopt, but it can be super useful. And the reason is because if you have a middleware layer, the API layer is just concerned with how to retrieve and return data. So, you're not having to build out multiple endpoints and data structures to expose the data that the client needs, right? Also, it can help increase API flexibility and decrease API development over time, because now the middleware layer is just going to expose one connection for the clients to consume, and it centralizes the business logic and all the common things like request logging and authentication. And on the other side for the client, because the structure and definition of the data is provided by GraphQL, then the client can just focus on consuming the data it needs and less about how to retrieve it. Another really awesome side benefit, I guess, is that the separation allows API teams to migrate to microservices architecture from maybe more monolithic API architectures. And you can do this slowly. And one of the reasons is because GraphQL is now, again, responsible for the client interaction. The APIs now can just evolve over time. And the client doesn't have to continue to make changes to keep up with the API and everything like that. And even if your company isn't ready for a microservices architecture, GraphQL acting as a proxy to your data, in my opinion, is good enough. So another advantage, and this is one of my favorite advantages to GraphQL, is faster prototyping and development. So again, there's so many ways to approach GraphQL adoption, but we definitely tend to recommend the schema first approach. So you start by defining the data structure and building your schema, adding types and queries, mocking out the data response, right? And the great part about this is the client can immediately see the definition of the data as it evolves, and developers can start developing against it using the mock while the real API and data layers are being built and validated. So, of course, this approach really requires adherence from the client and API sides to agree upon a data structure while development is occurring. But that upfront work is so beneficial. And, with this, you get decreased development cycles, decreased time to market, and, the client side developers can stop saying, hey, I'm waiting on endpoints from X person, which I think we tend to hear too much.
Way too often. Another really great part, and speaking about the client developer teams, is just GraphQL supports component-driven architectures really nicely. So as we've seen adoption of frameworks like Angular, React, Vue, all on the front end, what we're seeing is a lot of people are building these componentized front ends. And with these components, what we can do is we can actually tie GraphQL directly into those components and fetch the data that matches the schema of our components, or we can develop our components to match our schema. So what we're really seeing is GraphQL is almost a natural fit for this way of development. And it's really helpful with tools like Apollo Client because it'll also add some caching layer and allow some batch operations behind the scene. Again, we'll talk more about that in a little bit. But this lets all your components be smaller, stateless, and make them way more reusable across your system. Another great reason teams are adopting GraphQL, and probably one of my favorite reasons. I'm a big TypeScript adopter, and GraphQL plays really nice with TypeScript because it is a strong typed system. So in your non-GraphQL world, components are usually having to worry about protecting themselves against bad data from an API. You have no idea what that REST API is going to return, the shape, the form. Is the data actually going to be a floating point number instead of an integer? Is it going to be a string instead of a number? You have to handle all of those different use cases at the component level in that traditional system. With GraphQL, though, with its inherent system, it's going to force all those fields and types to meet that requirement. So now all that extra validation and overhead you've been building into your components kind of just can disappear because your API is now responsible for handling that. So you won't ever get data in the wrong format unless you change your API to be that way. So this is not only going to help on the data fetching side, though, it's also going to help on the mutating side of data. So think about any post request you have to make in a traditional REST system. You have to figure out, hey, how am I going to shape this exact JSON object to create that new data? What's great about GraphQL with its types is those inputs now become operands to the mutation operation. And you can see exactly what field, what shape, what data types they need to be. So before you ever make your request, you know exactly what needs to be sent and how it needs to be sent. So it's going to make building out any forms or user inputted fields much easier to validate and understand prior to even building it.
So I guess next is just teaching y'all how to actually adopt GraphQL. So we'll walk through our recommended approach to adopting it. And hopefully this approach shows you an easy way to adopt it and a safe path to migration going forward, because that's extremely important.
So, like we mentioned a little bit earlier, GraphQL defines itself as part of a language, and they call this schema language their schema definition language, or SDL. Alluded to it earlier. And what's really great about the SDL is it tells you exactly what everything looks like. So we've been talking about all the strong typing. We're talking about the shape. This is really where the power of that comes into play. So, kind of looking at our example here from our earlier example when we were talking about REST and how you could use it to get a user and its comments, we've decided to kind of break that schema down for you to kind of see how that could translate to GraphQL and how it's not a whole lot of code here. So in our case here, let's start at the top. GraphQL ships with enumerable types out of the box. So no more defining your own custom enumerables and having to have some crazy mappings on the back end. It's just out of the box, it's there, it works, plays nicely with pretty much every language that supports enumerables out of the box. Next, you can see we have a type object. And our comment object, which is a type object. So comments have an ID, a user, and a comment. Now notice, user is referencing a complex type. GraphQL lets us do this. It is a graph under the hood, so you can create all of these interdependencies. So user could be dependent on comment, comment on user, user could be dependent on another type that's dependent on it. And so you create this cyclical graph of how your data is going to be operating, which is really nice. And we'll show you in our demo a little bit about how you can do that. But in this, we can see that the ID and the comment of a comment are an integer and a string respectively. And on top of it, the bang operation is telling us that these are required fields. So if you require or request a comment and you request the ID or the comment, it has to be there. If it returns null, the API is actually going to have an issue. If we go look at our user type, we can see that we've just defined more types. The unique one here, though, is going to be the role is using the enumerable role that we defined above. Additionally, comments, as you can see, is wrapped in a array. And this syntax is just saying that comments are going to actually be an array of entities. So we can actually make user have many comments, whereas a comment only has a single user. Really helpful for explaining how our data works and visualizing it, especially when you go to build that page. Finally, at the bottom here, we have our query type. The query type is a special type in GraphQL. There are three special types: query, mutation, and subscription. Those are going to be our ways to retrieve data, mutate data, and listen to data. In this example, we've only shown the querying side, though. And what you can see here is we have a query called users that returns a list of users, and user, which retrieves a user by ID. And you can see the exact input output of each operation, how we can interface it, and what objects we get. So when we want to go create a page where we just want to display all the users, we could just get the ID and name using the users query. But then when we're ready to show them with all of their comments, we could show the ID, the name, and a list of all of their comments with all the comment strings. So really helpful, very powerful. Now that we've kind of have a schema, we can concern ourselves with how we're going to actually get the data. And the power of GraphQL is really in its resolvers and being able to utilize them appropriately. So the resolver is how we are going to attach those different types to the actual data in our database. The resolver at the end of the day is going to be what's responsible for retrieving, manipulating, or providing data to the GraphQL client. And this can be done in several different ways, which is why the adoption and the migration is so flexible and easy to do. So one way you could do it is using a typical service layer where you create your models that provide data into the resolvers in a unique way. Another option is you could create a database data layer where you're operating directly upon your database within the resolvers. Finally, and this is my favorite, especially when you're starting to talk about microservice architectures, is that you can actually use HTTP calls to fetch data from another resource from these resolvers. And because they're asynchronous, we're not going to be held up by waiting on other provided services. And Apollo, if you use that, will also batch all of these on the server for you as you're reaching out to those other services, which makes it really powerful and quick to get a lot of data very rapidly. So let's talk about kind of how resolvers look a little bit. So this is an example using the Nest.js framework for Node. And what we're going to see is we've just defined 3 resolvers here for simplicity of this demo, but we can do more. But in this example, we have kind of what does a user's resolver look like? What does a user resolver look like? And then the comments resolver on a user. So as we can see, users and user are both going to go just use an HTTP service. So like we mentioned before, you can use your existing microservice architecture or your existing API if you're migrating from a monolithic API, and just proxy all of your requests to your existing API and just use GraphQL as that middle layer. So let's talk about this final kind of comments resolve property at the bottom. What this is going to do is, if you remember, user allows us to have many comments, and we need a way to tell the comments resolver how it's going to fetch the appropriate comments for that user, because we don't want to just fetch all the comments in the system. We want to restrict it to only the comments that are focused on that user. So what's great here is now you can see we have a request to our comments endpoint where we have filtered already by user. So GraphQL has a lot of power here. The one thing that we haven't shown here is you can also write resolvers for specific fields. So for instance, let's say the role field. Let's say in our data, we actually did save that originally as a numeric enumerable. So 0 is a user, 1 is an admin. But we really want, that doesn't make much sense to our client consumer. We really want to display it as the enumerable type that we defined. We could write now a custom resolver that knows how to make that mapping from those initial integer values back into the string types that the consumer can now read and handle in a more appropriate fashion.
So we already talked about the idea of adopting a GraphQL middleware layer. And again, the reason to do this is because it really does make that incremental migration easier, right? And the reason it does that is if you build out a GraphQL middleware layer, right, then your clients can just incrementally adopt as the types and the layer are built out. So this is a diagram that shows you where the GraphQL middleware layer would actually fit into the architecture of your ecosystem, right? So previously what these apps would have done is connect to their own microservices, but now the GraphQL layer handles all of that for you. So the goal here, right, is to allow teams to communicate, to define and build out the schema. And as this build out is occurring and the middleware layer is being developed, clients, again, incrementally adopt, right? But the other amazing part about this incremental adoption is it's really going to increase the productivity and engagement of the engineers on your team, because they get to see this magical thing and quickly utilize and see the power of GraphQL as it's being built out. And it really starts helping simplify the code base because the business logic is starting to be centralized in this layer and being moved out from the client code. So now that y'all kind of understand some basics of GraphQL and kind of the business reasons of why you should adopt and how, one of the other amazing things about the GraphQL ecosystem is that there is an ecosystem. So we just want to quickly share some tools and resources to kind of help you understand what's available to you. So the first thing is the Apollo platform. Next slide. The Apollo platform is probably the most popular GraphQL implementation. It provides tooling to help you in building, querying, and managing your app's data graph. It also has Apollo server, and that helps you build out your graph's SDL, and you can actually connect that to existing data sources. The platform also supports incremental adoption. So it ships with a REST data sources tool for integrating your existing REST APIs. There's also Apollo Federation, and that allows for a gateway to sit in front of one or more of your API implementing services. And then also there's Apollo Client. And Apollo Client has libraries for some of the most popular front-end libraries like React and Angular. It also has a built-in client and it has built-in client cache and state management tooling out of the box, and it tries to prioritize fetching data from local cache to avoid server hits, and that obviously improves performance.
Another great set of tools is going to be some of the tool chain that Amazon's provided through AWS, and that's going to be Amplify and AppSync. These are tool chains created to help you quickly and easily create, configure, and deploy all of your scalable web applications through the AWS ecosystem. What's great about AppSync is it's going to use your schema to actually create and configure, maintain all of those AWS resources that you might actually need in order to operate on your query. So let's say you use DynamoDB, it'll understand what your schema is and be able to write to Dynamo in that same way that it's reading out of it. What's great about this is it's going to create that first-class API gateway that centralizes all of your middleware layer, say that 10 times fast, and it also supports Lambda functions for handling all of your resolvers and any advanced use cases. So this is going to really help you get started on any new project. Another great and awesome tool is going to be Hasura. Hasura connects directly to your database and actually builds out your schema for you based off of your database's foreign key relationships and field definitions. It also gives you the ability to lock down resources based off of roles and permissions, which is super helpful when you have a very complex and data secure layer. Now, one pitfall of Hasura right now is that they only support Postgres and MySQL. However, they're working on getting more database support in the days coming.
So, Dustin, I think you'll share really quickly, but we wanted to kind of share two tools. So Graphical and GraphQL Playground are IDEs for testing your queries, mutations, and subscriptions. What they allow you to do is connect to your GraphQL endpoint and allow you to then explore your schema side by side. So that's incredibly useful and awesome. And the other really cool thing about Playground is that it can actually be enabled on your server and directly connected. So if you're not using this, or if you just want to mess around with it, this is just an invaluable tool for reals.
And it's really easy to use. Just to kind of point some of the features I'm using. On the right-hand side, we have the Schema Explorer, and I'm kind of going through. This is, by the way, the Star Wars API for GraphQL. It's a free online one you can use, but as you're developing your own server, you can just connect to this with your local host. But it's really great. So now we can kind of see, here's a bunch of films, and I now want to see, like, hey, what characters were in each film? And as you can see, there's more connections, and I've used this API a few times, so I know a little bit about where I'm looking. But what you can see is we have some nice auto completion, and it's like, hey, you can use these fields to find the exact data you want. And it's got nice auto completion. We can see all the data. We can see now looking at all the Star Wars films here, we can see who was in A New Hope. Now, what's also super incredibly powerful about GraphQL, and this was the graph we mentioned earlier, is you can also do cyclical operations. So we've gone from films to characters. Now we're going to go back to films for a second. And what we can see is I can do the same operations that I did before. But now what I'm going to see is A New Hope, Luke was in it. What movies was Luke in? So now I get this nice cyclical operation, and I can see all the different data points I was looking for. I can see exactly the exact shape of the data that I got back, and you can also see that's filtered correctly based off of my types. Super cool, super powerful way of using GraphQL.
And that is really the end of our talk, but just wanted to give a shout out to, if you care about JavaScript, which, you wouldn't be at JSWORLD if you didn't. So, come check us out. We do GraphQL contributor days, state of GraphQL. We do all of these also for Vue, React, and Angular. So a lot of really amazing content out there. You can go to javascriptmarathon.com. Every other month we do just like a day of free trainings, which is really amazing. And we're also hiring. So definitely, again, hit us up, send your resume. It's 100% remote worldwide. And, it's a fun team to work with. I love going to work every single day. So thanks everyone for listening and hope to see you around the internet.
Bye, y'all.